All right. We are on, well, our first functions lesson of the year. And a great place to start is with linear functions. Okay? Anytime we're dealing with a coordinate plane and talking about graphing points and this type of thing, it's a great place to start. Okay? Now I'm going to add to this 1.1. I want to call it just day one. We're going to spend a couple days, and for these videos, 2 lessons worth of material just to get started on this first section. Just talking about points and lines, which is a great place to start when you're talking about an XY coordinate grid and plotting points and dealing with functions. Okay, really important to note right here the sloped intercept form of a line. M equals our slope. B is our y-intercept. It's a great form of a linear equation to use. It tends to be pretty user-friendly of all the different forms that we have. Next to it, or I should say underneath it, is general or standard form. Okay. One thing I want to make note of here is I still want to take a peek here with this discussion of slope and y-intercept. Now, what's cool about the slope-intercept form is that information is ready and available in the form the equation is written. That's why it's kind of a nice form to work with. The information you would want to make a graph is very accessible. Okay, general or standard form, I want to point out here, we can do a little algebra to get this information, and in fact, it's worth doing a little extra work right now to make note of a pattern. So that we could document this, write it down, and come back to it in the future. Okay? What I'm getting at here is if we were to solve this for y by subtracting a times x from both sides for the first step. Okay? I actually want to take this and essentially put it in slope-intercept form. Well, after that first step, I am left with b times y equals c minus a times x, which leaves me one more step to get to slope-intercept form. That would be dividing both sides by b. I get my y variable all by itself, which is fantastic. Dividing both components by b leaves me with c divided by b minus a divided by b times x. And in this completely arbitrary variable-filled form, I've actually got it in slope-intercept form. Now, referring back up to here with slope-intercept form, okay, the slope is whatever is coming in front of x. All right, so if I am referring back to these parameters, a, b, and c, okay, for a general form of a line, the slope is actually always going to be the opposite of a in terms of its sign, take the opposite, divided by b. And the y-intercept is going to be quantity c divided by quantity b. Okay? So the point I'm making here is that with general form, it's not that stuff like the slope or y-intercept is impossible to find. It's just not as fast and as straightforward as slope-intercept form. Okay, but this is something you could refer to in the future, okay, that you may come back to say, oh, if I've got a general form, negative a over b, that's always the slope, instead of having to always do this work and rearrange it to get it in slope-intercept form. Let's scroll down here and take a look at an example or two of determining if a point is on a line. Really straightforward. Plug in the points for the respective variables that they belong to and see if it works. For the first example, this point I have, remember the x-coordinate comes first. That's a fundamental component that you probably remember, but if you don't, okay, important to make note of that. X comes first, then y. So if I were to check here, I'm taking 3 times 4 plus 2 times 3 and checking to see, does that equal 18? Okay. Now, really small down here, I'll just point out that this simplifies to 12 plus 6, which clearly adds up to 18, and that means that that point, okay, is a solution to the equation that we were looking at, this line that's in general form. Okay, we plugged it in, it worked. It's a solution. Now on a graph, what that would imply is that this line, okay, goes through that point. We can try it with another one here, and we will see as we put in 5 for y, -1 for x. We start to simplify a little bit. 1 plus 7. And we get to a very interesting equation that states that 5 equals 8. I don't think so. That is not true. And here we have the opposite case where we see that that point, if we're talking in relation to this equation right here, not a solution. That point is not on that line. Okay? That's how we'd go about checking if a point is a solution to a given line. Distance and midpoint. Here they are. The next logical step, really fundamental stuff when we're talking about the XY coordinate grid. Okay, allows us to take any 2 points and determine 2 things. Number 1, how far apart they are, and number 2, where's the location that's exactly halfway in between. These 2 pieces of information are really important. Okay, with the distance formula, the answer is a length. It's just a single number, whereas over here with midpoint, okay, our answer is a coordinate. Okay, and we should have an x component and a y. So we're going to start with this example right here. All right, if we were to plot them, this would be 5 points to the right. I am very aware this is probably a little bit small and difficult to see, which is okay. The graph here is really not the focal point of what we're going to do. We've got 5, 1. And we've got 1, -3. Okay. We'll start with distance. Okay, this is really what I'm after here. We would take the difference of the x's, which would be 5 minus 1 squared, plus the difference in the y's, which would be -3 minus 1 squared. Now it becomes a game of simplification. 4 squared, let's see, this would become -4 squared. In fact, why don't we jump ahead a couple steps here. This becomes 16 and 16 because one simplifies to 4 squared, the other -4 squared. For both of them, however, all roads lead to 16. All right. Now, it's talking here about giving your answers in exact form. If I wanted to, I could take the square root and give a decimal approximation. However, I want to talk a little bit about exact form where we leave the square root. Square root of 32 is an exact form. It's just not completely simplified. I could take the square root of 32, and I could split it up as square root 16 square root 2. I'm hoping that this, for you, begs the question of why 16 and 2 seems like kind of a random thing, random step to make. That was really all about pulling out a factor of 16. Okay, 16 is a very special factor. It's a perfect square. The square root of 16 simplifies to 4. Nothing I can do with 2. That's a fully simplified answer in its exact form. 4 square root 2. Okay? So that would be the exact distance in between. Last piece we'll touch on here is midpoint. I'm going to use the same 2 points here. The x's, I would average them. 5 plus 1. The y's, I would do the same thing. Negative 3 plus 1 divided by 2. 6 divided by 2 would be 3. Negative 2 divided by 2 would be negative 1. And there is my final answer. And notice the difference here. With the distance, it's a number. It's a value that represents the distance between those points. And with midpoint, we get an actual coordinate point. Okay? That's really the basics of what you need here to get familiar once again with those forms of linear equations, both y-intercept in general. Know how to check a point and get familiar again with distance formula and midpoint. All right, and that will be all for day 1 of 1.1.